Hi guys, my name is Toh. I'm head of engineering at Exhaust Systems, a small 15 people company doing like software for electricity billing for retailers and distributors. So we use Ruby. We have 3 applications that uses Ruby's and yeah. So recently, in terms of data engineering, I'm gonna say this first that I'm not an expert in data engineering. It's a journey that I have been recently gone through because our board members was looking for some sort of like additional kind of products to offer to our customers in the likes of data warehouse, data lakes, all these simple terms that you might have heard of, but so I haven't finished the whole thing yet. So I'm in the journey of like exploring like the options or what business business case can be done. But in terms of what my findings and relating to the Ruby application, like the Ruby programming language and Ruby on Rails, I have found something that's kind of like maybe help enhance what we are already doing, right? Because we Ruby guys doing most of you, if you deal with Ruby, you might use Ruby on Rails, which is like traditional web application, like software for building web application that's good for transactional processing and not necessarily dealing with data. So and also like Ruby is sort of in the dust by Python or other programming language in terms of handling data stuff like that, right? So I'm going to share here one of the concepts that I found very interesting and it might be really useful for you guys to do because it's easily adopted as well. So there'll be a little bit of live demo I'm gonna do as well. So yeah. So in terms of data engineering space, it's huge. So this is the landscape of just the open source. There's a lot of them you can choose from to learn what they are, use them, and kind of like trying to make use out of it. But what do you use? Like there's so much, right? So whether you build a data pipeline, you build kind of like your data lake, what is data lake, what is data warehouse, or how do you transform your data from your source to like the kind of like the final product of data that you want. So I'm not going to cover most of these. Like I'm going to cover a few of them that's notable, and yeah, and this is just open source, and this is like including like commercial products as well, like the likes of Databricks, Snowflakes. You might have heard of those products, but I have explored something like Databricks, Snowflakes, but not gonna use them because they're quite expensive and just end up coming back to some open source stuff. So in terms of Ruby, the bad news is Ruby has nothing to do with these at all. None of the product has been built with Ruby programming language. That's the reality, and how do we deal with it? Like how do we keep ourselves modernized and maybe use some of the concepts that might be great in this space to kind of enhance what we do in our applications. So I'm gonna just show one among them. I'm not gonna tell you yet, but to do that, I'm gonna just do a demonstration. This is interactive as well, so you guys can kind of like join in if you want. We're gonna do a little bit of speed competition. I'm gonna ask you guys to write Ruby functions, as small Ruby functions that sum a column in a CSV file. Sound simple? So I have already asked ChatGPT to do so. So this is just a simple project I did, right? So there's a definitions there. ChatGPT will write me that code already. Get CSV for each file, do a column value, sum plus equal to column of each column value. So you just give in the file and what column name you want to sum. So I have a data here that I stole from this morning from my testers. There are 200,000 lines of CSV data. Yeah, you see what I mean. Like, so yeah, 200,000 lines, and right now with ChatGPT code, I'm just gonna run this right away. So I just, all right, okay. All right, I'll just move this away. Is that good enough? Okay, so I'm just gonna time how fast ChatGPT performs, right? So I'm just gonna run this, which I have already do a start time results of the calculations, the end time, and then just do an elapsed time and print out how long does it take. So that thing, just gonna run that. Take a couple of seconds. So it takes 2.7 seconds. Does anyone want to compete here? Anyone? Or you can tinker the existing ChatGPT code here. Does anyone want to give it a try? I'll buy you a dinner if you can. If you can beat ChatGPT, or if you can beat my sheet as well, I'm gonna cheat. Does anyone want to give it a try? AJ, if you want to.
My cheat is this call to, or a call to Miller or something.
Say that.
Call to Miller.
You want to come and try? No.
It's not Ruby. It's cheating.
Oh, it's cheating. Okay.
Yeah. We would both cheat.
You always cheat. Okay. All right. Okay. No one then. Okay, that's all right. Yeah, I'm gonna go straight to sheet right away then. So if I'm gonna write this one, I'm gonna sheet which I'm gonna use a library, obviously, which belongs to one of these. One of these tools here. But anyway, I'm gonna use require polars here. Does anyone know what that is? Okay. That's good. that means I'm not getting embarrassed. Okay, cool. And over here, I'm gonna just do a df equals to polars dot. I'm gonna read from CSV file, that file, and then I'm gonna do df column name. Don't give me a suggestion. Come on. Dot sum. Yeah, exactly. Yeah. Good suggestion. That's it. Okay. I'm gonna time myself against ChatGPT. So I'm gonna just copy and paste that down here, and this is my sheet. All right, not chat sheet. All right, and then over here is sheet as well. All right, results. Okay, save. Now I'm gonna run it. ChatGPT took 2.7, mine took 0.1. 27 times faster. You know what? Does anyone know how what's behind this thing?
Is it a thing not written in Ruby?
It's not written in Ruby, obviously.
I'm guessing probably a C implementation or
It's
data library.
Yeah, it's actually a Rust library. It's called. I'm gonna go back to this slides now. So what's behind this gem, Polars gems? It's called. It's a tool called Polars. It's a data frame kind of library. What anyone know what the data frame is? Yeah.
Yeah, I've used pandas.
Yeah, exactly. Pandas, NumPy.
Yeah.
So it's like a data structure that's in table format, right?
And you select a subsection.
Exactly. So you basically you have your you take data tables in memory in the variables, and you manipulate, just similar to how you manipulate your data in SQL format, right? But this is in memory in the data set. It's a data structure. That if you use pandas and NumPy, you will be familiar with it. But but Polars take it to another step on top of pandas, and pandas is following up Polars on this as well. Polars uses a technology called Apache Arrow. If you might realize, Apache has been involved in a lot of these data processing projects. The Apache Spark, Apache Flint, Apache Parquet. There's a lot of these Apache projects that have been done by these brilliant mathematicians that kind of come into this data space. And this gem Polars is basically written in Rust. It's the same library that's been used in Python as well, but it has a binding in Ruby, so you can use it by just using that, importing the gem. That basically, I'm going to show that as well. And why is it fast? So with data frame, it's a storage that is column-oriented data format. With traditional CSV file or JSON or the likes of data, from the database that you pull, right? They are row-based format, and every time you have to process the data, you have to go row by row, right? So that takes time, because if you have 1,000 rows, you have to do at least 1,000 operations to do those rows, right? But with column-oriented data format, it's much smarter than that. It can go up to just one operation to do all your calculation at once. And I'm gonna explain this is why this can happen. And when I do the this part of df.polars.csv file, so what's happening here is I'm reading this file from data, right? And then it will be stored in this df, which is a data frame. So everything is in memory. The whole set of 200,000 rows of data in this CSV file is now stored in this df data frame, which is a column-oriented and in memory right now. So that's why you can process this thing really, really fast, right? And when you read the data, it's like a constant one operation time to read from the data as well. And yeah, so it's in memory processing, and there's terms here going back to a little bit of machine learning concepts, or what do you call linear algebra. If you have learned a little bit about how machine learning kind of calculates the model. So basically, and this single instruction multi-data is the same concept of how GPU works versus the CPU. So in this, let's say you have data like that, right? So you have data rows, and then you have your columns, right? Usually in the traditional memory buffer, how you deal with your row-based data that you pull from the database, from the CSV file, it's actually arranged in this format, and then when you process it, you have to go row by row. So if there are 100,000 rows, you do 100,000 operations, right? But in the column, but that's what I come back to, the column-oriented data format. Now the data is being arranged in column-oriented. So all the columns here are being stacked together in the same, in adjacent memory. And this allows the computer and the CPU, you inject the whole set there into the CPU, and you just do one operations. So the whole thing can be calculated depending on how how strong your CPU is. You can go up to just one operations to do the whole thing. So that's why it's much faster. And yeah, that's why it says single instruction, but you use you can do it over multiple data depending on how strong your CPU is. And if you can even use your GPU, you can just go nuts with that thing. And that's how GPUs used to render all these bitcoins, graphics and stuff, and doing really intensive computation, and because it uses this concept, right? And vectorization is basically the mathematical concept for this thing, where you arrange your data into one column, and and then when you do some mathematical operation, it's just one time, not n, right? Any question here? Yeah. Cool. And with addition to this, I want to also introduce you to Apache Parquet, another Apache project again. And with these concepts, right, what it means is it might not be a good idea anymore for you to store your data in the database, but in a flat file. Apache Parquet is a flat file, and I'm going to demonstrate to you this why is it good. Apache Parquet is a flat file that's being produced using the columnar format as well. So when you load this file into a memory or CPU, it's going in like that. So there's no need for the computer to arrange that into a columnar format. You just load the whole thing in a columnar format and it's ready to be used by the CPU. So let me just give you a demonstration here. So I'm gonna just use this thing. I'm gonna just run the IRB console. Right. I'm gonna require this thing again. Polars, if I can spell. Okay, cool. Now I'm gonna do this df equals to polars.read CSV again. CSV and that file, which is data.csv. Right. So now this df has a shape of like it has 200,000 that amount of row, and if I do this df, it's gonna this is like a data structure project. It's already built into as for your tables, and you can manipulate anything with it now. Like if you're gonna print the first line of the thing, you can do join, you can do sort, you can do group by, whatever like it takes. Like it's similar to how you do your database, your SQL, right? It's similar thing, but now you do it in memory on the application server instead of on the database. So okay, get back to Parquet. So with this df, I can write to Parquet, write Parquet, yep, that one, and I'm just gonna say data.parquet file. Okay, cool. I created a Parquet file, which is exactly the same data as a CSV file. I mean, I click into this, I can't see anything because this is a kind of like a compressed data in a columnar format. So it's not human readable basically. But if you look at the size of the file, actually where is that? So demo. Look at the size. Compare the size of the file. That's data, and that's Parquet. Same data in like same set of data, but that's the size of the Parquet file. So in the data engineering world, there's a concept of these data lakes, data warehouse, which I'm gonna kind of relate to the concepts of why you might not be a good idea. I wouldn't say that it's not a good idea. It might not be a good idea to keep your data in database anymore, because traditionally when you pull data right from any source, you extract it into a CSV file, JSON file, as API, or whatever it is, right? You transform it into your SQL and then you load into your database. Simple, right? That's what we do, right? But the size of that database will be equal to the size of the data, right? But so, and that's the concept of like ETL as well. Like so, this whole concept is called ETL because you extract, transform, and load. So you extract, transform, and load, right? But in that, if you heard about data lake, data warehouse, these new concepts, they pretty much switch around it, L and T, extract, load, and transform. So what is now they're doing is like with the data source, you extract and you dump everything into a data lake. So the data lake is basically a place for you to keep all of your data, structured, unstructured, doesn't matter. It's just like I don't want to say it's data lake. It's like more like a landfill. You just dump everything in there, right? Just your data, it's all your file in there. And then you basically use a data pipeline technologies, which is like, there's a lot of these data pipeline technologies up here. Databricks is one of them. Data Snowflake is one of them. You can use, and basically they have these engines that uses, all these columnar format to process the data into your data warehouse. And a lot of places uses S3. So this is S3, by the way. Amazon S3, it's what's the equivalent of Google, and yeah, there's a place for you to store your file, or in Google Drive maybe, right? And they have like tiers of data that kind of like store that buckets that store. Maybe the first bucket is where you store your original data, and you do the transform into a Parquet file, and you store it into like, oh no, it's not here. Everything is one. I forgot to change the tier a little bit there, so this should be 2 and 3. Sorry about that. Copy and paste. All right. Yeah. And they have these terms of like bronze, silver, gold, and maybe if you want to go up all the way to the uranium, how you want to kind of tier up your data processing. and you keep it in the S3 bucket as a package file, because when you load it again with those tools, it's going to be in columnar format no matter what. It is faster for processing instead of keeping it in the Postgres, which is a transactional row-based database, which is much slower, right? But there are drawbacks about it as well. Like the package file is not easily editable. So if you're gonna change the data, update the data a lot, so it's not recommendable. If it's like a raw data source that's just there, and you're not gonna delete it, you're not gonna update it a lot, but you use it to process your data. Things like the electricity with like your meter reading, for example, no one's gonna change that, right? So just that kind of source of data is maybe one of the things that you might want to use this method of doing a data pipeline, having tiers of data of processing, instead of pushing everything into the database, Postgres, which is transactional and slow, right? And which comes to the concept of OLTP and OLAP. So there are OLTP is online transactional processing. Your regular Postgres, MySQL, MS SQL, they are all online transactional processing. So they're great for constantly writing, updating, reading, all these general concepts. But they're slow, compared to just like how I compared just the row-based thing to the column-based thing. So, but with the column-based processing, analytical processing, there are certain type of database that does this as well. So there are the likes of going back here, like these DuckDBs, Pinot, Apache Druids. So they pretty much store the data in the columnar format as a database. But I have never used them, so I don't know pretty much about them, how they're going to be different from like if you're going to keep it in your Postgres or MySQL. But yeah, there are these new tools which are online analytical processing, like focus on that, uses like the columnar kind of technologies to do a faster processing instead of the traditional online transactional processing that we are using. It doesn't mean that we don't want to use this. We want to use this for our regular database that still needs to update, delete, change a lot. But if you have data that's kind of quite static and used for analytical, then it's much better idea to keep it in the OLAP database to do your processing. So in terms of the use case at my place in Exhaust, I'm just gonna talk about the background a little bit first. But because we have these Ruby on Rails application, right, which all of them, we have three apps, which all of them uses Postgres database. But with our apps, we do a lot of reports, we do a lot of dashboard processing as well, and these things require us to write like hundreds of lines of SQL to do such thing. And whenever one of those like low performance SQL get run, the database is dead most of the time. So the thing is, we don't want to keep all those analytical processing inside your transactional database. So our use case is now I'm using Polars at least to do this data frame, like joins, group by, or sorting, some stuff like that, right in the application server instead of what's happening in the database server. So the database server now only pulls data for the application server, but the application server now use Polars and the data frames to kind of do the analytical processing with that Polars. So this is a use case that I'm doing right now. Like for example, this kind of SQL rows that used to be there, dealing with 3 million rows, the simple one like that. With SQL, it took 3.2 seconds to complete, but with Polars that I use, it's just 0.1, 0.2 seconds to kind of complete that thing. It's not just about speed, it's also about splitting the load, right? You don't want the load to happen on your database a lot. You just want it to serve you data, your CRUDs, basically. You don't want to do group by, a lot of complex joins, a lot of unindexed search or something like that, right? Which might be better to use in the data frames. So yeah, that's pretty much it. it's still in the journey of doing this use case. When I was meant to speak this a little bit later when we have more results to show, but since we don't have, when AJ asked me, there's no one speaking, so I was just like, okay, whatever I have right now. So, but hopefully I'll if this thing goes through, then I can probably come up like later and share how that's gonna be going. Yeah, that's pretty much it. Cool. Any questions?
Ooh.
Yes.
Have you run a RAM yet?
That's a good question. Yeah, that's one thing we have to be careful of, not to. I have tried to put like all, how about like 1 billion rows of data into the data frame in my laptop, and that's that it doesn't go well. So it's something we have to kind of like turn the knobs a little bit and find out like how do we deal with this thing, and it's we also might have to have upgrade our application server to be more RAM, memory efficient, or like upgrade the RAM in that space. But we can then lower the resource intensiveness on the database side as well. So it's just a trade-off. But yeah, I have one of my juniors who just graduated in like with machine learning and data processing stuff, doing this thing for me. So yeah, hope he does it well. Yeah.
What does your pipeline look like? So you talked about moving the data into the application server.
Yeah.
Is that like a scheduled thing that just dumps Postgres into the Python formatting?
I haven't got to that steps yet, but that's what I'm envisioning. Like we might spin up a few buckets of S3, and all the data that we pull from the outside source that we usually process, maybe we keep it in a Parquet. Maybe we keep it in database as well. We have to see how it goes. But yeah, that might be the outcome of if as I go on trying to make this work, but step by step. So right now I'm trying to put polars in to at least help the database server not to process all these like expensive queries. So that's the first step, and then maybe I'll deal with the pipeline of data, how data flows through my application further. So yeah, it's a step by step. I have to think like modify the plane as it flies. So I can't just build the whole thing out of the blue. So yeah.
We had the different times. I presume that was like it's to pull quite a lot of data from the database.
Yeah.
So does that include like the time to pull the data down
Yeah.
and then process it? It was
Yeah.
still quicker. There's an interesting like trade-off with it. So it's like less because normally we're trying to like move do that computation on the database to reduce the amount of like traffic. But if it's actually easier to move millions of rows over the network just to process it in Ruby.
Yeah.
Not in Ruby, but
Yeah, but that's something we can be sure of. So it's we have to do experiments as well. Like right now, like even if database can even do some like simple joins, like say 2 joins together, right? That might be better to do in database before it spit out the data, rather than pull the 2 tables out and join it inside of. So that's where we have to kind of like do a little bit of engineering in terms of like which one is better, which we should do. Yeah.
How can you limit the amount of data that you're pulling in at any given time, or is it just like?
I think there is. Yeah, I think there's. I haven't explored the tools enough. I'm sure there might be some, kind of like safety net to protect you from exploding your RAM. Yeah, I'm pretty sure. So, but yeah, that's something to explore right now. But haven't deep dive into the tools enough. But yeah, it should. Otherwise, we have to come up with something. Yeah.
How does the performance? So you mentioned like you can do like joins and filters and stuff.
Yep.
How does that? If you start, say you've got like a pipeline of like 4 or 5 files, you're like intersecting and joining and stuff. How does polars speed compared to SQL?
It's much better. Yeah. In terms of if you join doing group.
Joining like a columnar format.
Yeah. Yep. It's so interesting to use it for your next tax run. Yeah. Yeah. So how long did you take for you to run on your machine last time?
The Postgres bit, 10 hours.
10 hours.
Yeah.
Try that.
I did forget to back from the database before.
Okay.
Did you find anything similar in the gigantic AWS console, like a BI
like there's tools like AWS Glue, which basically an extractor of data, and then they said to put it into S3, and then use Amazon AWS Redshift, which is equivalent of like Databricks or Snowflake, to process the data and just move data around, process it, put it back in the S3 in different tiers. But the AWS account manager says like don't use that, just use Databricks. It's a better tool. Yeah. So, yeah, and one of the other things, if you want to explore about this thing, right? Like there's a lot of Apache projects, notably the Apache Spark. Where is it? Here. You know, Apache Spark is open source. It's an engine that does a lot of like batch processing or all this columnar like processing. It's basically the engine of Databricks. So it's open source. So if you learn how to use that thing, you can basically use whatever Databricks can do. But Databricks provide you with like quality of life where you connect to your S3, you connect to Azure or whatever it is, but giving you a good UI, good like schedule jobs, setting things up like that on the fly. But yeah, there are tools here that you can actually leverage off by your own for free to achieve whatever you want to do. But it's humongous. Don't ask me about all of it, but yeah, just yeah.
What applying machine learning techniques
Can you speak a little bit louder?
for applying machine learning techniques on this data set, the speed is the same like the normal table, because when we apply machine learning, we need some of the all features of each data
Right.
that are in there.
Yeah.
In each row for each data.
Right.
So when we use this column-based data, we should take each feature from different rows for each data.
Yeah.
The speed is different.
Yeah. I have no idea. I mean, I haven't dived into machine learning or in that processing yet, but I wouldn't say like something is faster than the other. I think you have to try it out and kind of see the situations. Sometimes transactional processing might work for certain reasons, and for some other reasons, like analytical processing might be better. So I mean, and I've just started too, so I'm just sharing things about here that relates to Ruby, so I haven't dived into that area too much. Sorry. Yeah. Any other questions? Haven't gone over time. Sorry.
No, you're good.
Right? Okay, that's it. Thank you.